All right, 5.2 mean value theorem. So, it's like sitting in 5.1. I'm like, we just did that. State whether or not the function satisfies the hypothesis of the mean value theorem on the given interval, and then if it does, find each value of c in the interval a to b that satisfies the equation. So, they give us f of x is equal to x to the 2/3 on the closed interval 0 to 1. So the first thing we're going to do is to find the derivative, and then we're going to evaluate that from our two endpoints, because the mean value theorem is f prime of c is equal to f of b minus f of a over b minus a. So essentially we're going to see if the derivative evaluated at the point is or like what it's like showing what it's equal to, and then we'll go from there. So essentially there's like a few scenarios where like the mean value theorem won't apply. This one is not one of those. So first take the derivative. So f prime of x is equal to 2/3 x to the negative 1/3. So this is just f prime of c. Well, in this particular problem, they didn't give us c, so I'm just going to replace x with c, and I'm going to solve for c and see what it's equal to. But I know that, like, this is a continuous function. Like, it's just x to the 2/3. Like, there's no issues or whatever on the interval that I'm on. So we would say 2/3 c to the negative 1/3 is equal to, and then we're going to use the mean value theorem. So the original function evaluated at 1 minus the original function evaluated at 0. So basically we end up with, just so that we can see it, 1 to the 2/3 minus 0 to the 2/3 over, the bottom is just 1 minus 0. Ordinarily I would just write it as 1, but so I have 2/3 c to the negative 1/3 is equal to 1. Multiply by 3/2, so c to the negative 1/3 is equal to 3/2. Technically this is getting into part B now, because they want us to actually solve for the value of c. And there could be, depending on the equation, there could be more than one possible value of c. If it's like, we're taking the square root, you could end up with like two values, whatever. So technically speaking, this is 1 over c to the 1/3. So we need to basically cube the whole thing, and then I'm going to have to flip the fraction over. Or, well, it doesn't really matter. I would cube the whole thing first. So cube it. Then that just gives me 1 over c is equal to 27 over 8. And then if I'm solving for c, I just need to flip both fractions over. So c equals 8 over 27. So that's the value for part B. So technically speaking, like with this problem, the first part is really just setting up the mean value theorem. So really at this point right here is really where part B starts, because this is like my mean value theorem. Well, technically down into here since it's just 1 and 0. But whatever, like, this is all they're asking me for in part 1. But the areas where like this wouldn't apply is if I have like the corner, a cusp, a vertical tangent, or I'm trying to think what the other one is called. Corner, cusp, vertical tangent. the other one is. 1 second. It's not that section. I can't find it right now. I'll have to find it later. But anyways, those are the main ones, the corner, cusp, and vertical tangent, that it's not going to apply at. So like an absolute value function, the functions that are like that's like the vertical tangent ones where like they can't cross that or whatever. And then the cusp ones are the ones that are like the bird. Okay. So anyways, relatively easy as like just plugging in this stuff. So 4. F of x equals the absolute value of x minus 1 on 0 to 4.
Sorry to interrupt. Can I ask a quick question?
I'm currently teaching. Can you come back during 4th hour?
Yes, ma'am.
Okay. Guess he didn't read the email response that I sent him last night when he sent and asked me a question. All right, so this one is an absolute value. The other thing to pay attention to is the interval that they're giving me, right? Because this absolute value function has been shifted to the right because it's the minus 1 inside, so it's gone over to the right. So that means that it's inside my value of 0 to 4. So that means that I have a corner inside of that value. So that means that this one does not follow the mean value theorem.
How do you know it has a corner?
Because it's an absolute value function.
Oh, okay, yeah, that's true.
So if it was shifted the other direction, then I could still do it because of the interval that I'm on. But because, like, if it was +1, meaning it went to the left, but I'm on 0 to 4, my corner wouldn't be in the interval that I'm using.
Oh, okay.
But this one is because it's been shifted over. So basically this one we don't have to do anything. You just say, no, there's a corner at x equals 1.
Wouldn't it be okay, though, if x equaled 4? Oh, wait, never mind.
Yeah, it's like on the whole like interval thing, because for the mean value theorem to apply, it has to be differentiable at every point inside, and it wouldn't be differentiable at x equals 1.
Yeah.
6. F of x equals the ln of x minus 1 on the interval 2 to 4. So one thing just to remember with logs is we can't have a negative inside of the log. So, and we also can't have 0 inside of the log. Yeah, because there's nothing that could be equal to that's going to force it to be equal to 0. So, basically 2 to 4 does work, but if it was pretty much anything to the left of the interval of 2 to 4, I wouldn't be able to do this one. It wouldn't be differentiable. But 2 to 4 is good because when I plug in 2, I have a positive number, and obviously 4 is a positive number. So that means with this one I'm good. So I need to first take the derivative of it. So f prime of x is 1 over, so the ln of x would be 1 over x. So this would be 1 over x minus 1. Derivative of the inside for the chain rule is just 1, so I have the chain rule, but I don't have to do anything. So we're going to swap x with c for our f prime of c. So we've got 1 over c minus 1 equals f of b minus f of a. So this is going to be the ln of 4 minus 1, so the ln of 3 minus, plug in 2, the ln of 1, over 4 minus 2. So then do you remember what the ln of 1 is equal to?
Wasn't it E or something?
Well, e to the what is equal to 1, if we wanted to
Zero.
think about it. Yeah. So the log base whatever of 1 is always going to be 0, because whatever the base is raised to 0 is always going to be 1, because if you, just a refresher. So we would say this, so then we do the little e thing to solve it, so e to the x is equal to 1. The only way for that is for x to be 0. So, that being said, that's 0. So I have, again, technically this is part A. Getting into part B, 1 over c minus 1 is equal to the ln of 3 over 2. I'm going to go ahead and swap these two, flip these two fractions over. So I have c minus 1 is equal to 2 over the ln of 3. Then add the 1, c equals 2 over the ln of 3 plus 1. If you don't have your calculator, that's pretty much your only option, but this is equal to 2.82. Because obviously on the exam, some questions you'll have your calculator and some you won't, so just depends how they give it to you. Let's see. Time we get out of here, 9:50. Okay, we stopped. 12. This is a temperature change problem. I'm not going to write the whole problem because it's kind of like a little short word problem, but it took 20 seconds for the temperature to rise from 0 degrees Fahrenheit to 212 degrees Fahrenheit when a thermometer was taken from a freezer and placed in boiling water. So basically we went from 0 degrees to 212 degrees in 20 seconds. The other stuff's kind of irrelevant. Explain why at some moment in that interval the mercury was rising at exactly 10.6 degrees Fahrenheit per second. So essentially, just to kind of look at like a rough graph of what this would be like, basically I've got my time down here. So I've got 0 to 20 seconds down here. And then over here on this side, I've got degrees Fahrenheit. And that's going from 0 to 212, basically. So in theory, right, we would be rising constantly. Like in normal circumstances, it would look something like that. However, that's not really what's happening. It's going to basically do something where it's like it's rising more like that with like a curve to it. So we're trying to show that at some point in this interval of time, it's raising at 10.6 degrees Fahrenheit per second using the mean value theorem. So this value right here is essentially our f prime of c that we're dealing with. And then this information is giving us our f of b minus f of a over b minus a. So the y values are my degrees. That's why I did like a little graph here. And then my seconds from 0 to 20 seconds is my interval for my a to b. So basically, I've got the interval 0 to 20. And then these are the values. At 0 seconds, it's here. At 20 seconds, it's here. Okay. So we would have 212 minus 0 over 20 minus 0. Now, obviously, ordinarily, if I was actually solving this, I would probably not be writing the zeros, but to show that I'm using the mean value theorem, that's why I'm going to write it this way with the zeros in here. And then we're going to show that that's equal to 10.6. So we're technically not solving anything with this problem.
You're just showing.
We're just showing that we could use the mean value theorem. And then kind of to like wrap it up, we would just say, by the mean value theorem, at some point, it had to be rising by exactly 10.6 degrees Fahrenheit per second, basically. Is just kind of how we like wrap those ones up. So, there are some other ones, like the speeding one is probably like speed and then temperature are probably like the most common ones that I would say like to really like be concerned about. There's like some other stuff, but those are like the main ones there. Let's do this. Let's pause here. That's a good, because the next stuff is like a few problems of the next type of thing, where we're doing increasing and decreasing and whatever. And then we'll do some antiderivatives tomorrow as well. Do you want any problems or no? I don't care. I'm just, okay. This is a pretty short section. I would say either Thursday or Friday we'll quiz. It'll really depend on if we're at school tomorrow and for how long. I mean, if we have at least as long as we had today, we'll finish the section tomorrow. And then we would be able to quiz on Friday. Or, well, we could quiz on Thursday, but we can bump it all the way to Friday if we need to. I mean, I do not expect that you're going to need to take the exams, so.
No.
But I would say, you know, in the event that we're out of school tomorrow, maybe take your stuff and just refresh on 5.1 so that you don't forget it, since obviously we've had a few days off of that. Because we'll get a little bit of a review with what's left of this section, though, because we're going to be finding either like a min or a max or both in some of these problems. And then showing where it's increasing and decreasing, which is basically just like between a min and a max. Obviously, it's going from a min to a max, it's increasing. If it's going from a max to a min, it's decreasing. So it's just finding the intervals between those two things. So it's kind of like the next step of what we were doing. And then after Christmas, we'll do concavity and all of the things that I was going to try to get to before, but it's fine.